Hi, I hope you enjoyed your lunch. I'm Nils, I'm from DATEV, and I'm working on the IAM program at DATEV. And today I want to show you how we use Neo4j to protect data. So DATEV, who are we and what's our business? We are a cooperative based in Nuremberg, and we provide services and software for tax consultants, auditors, lawyers, and their clients. Our biggest assets are that we provide high-quality services. All data are hosted in Germany in our own data centers, and we have the highest security standards to protect our customers' data. So, as I'm talking about our identity and access management system, I want to start with where do we come from. We started off with a clear hierarchical system. So we had customers, and those customers had clients, and we provided services for them. So that is somehow how it looked like. There were only relationships between clients and our customers to us. But as often, things change over time. And our customers' clients demanded to collaborate with more than one of our customers. So we ended up in a system like this, and we managed to extend our system. We already had to use collaboration like this, but we did this at a cost. We had to do some very big manual management on our IAM system, and that meant high costs and a little less security, because there was always manual administration, and with manual administration there might be some faults. And how it often goes, things are changing again. So now our customers' clients want to collaborate with each other, and maybe they even want to collaborate with us. So that's what we end up now with. So you see, everyone wants to collaborate with everyone else. So what are we aiming for in the future? We want to build a new IAM system that fits our needs again. But we want to keep our level of security, and we want to provide secure access to data, and we want a system that has collaboration built in. So not collaboration by accident, but collaboration as some kind of first-class citizen in our system. So the solution we are coming up with is an access management system with multiple lines of defense. The first line of defense is what Neo4j is used for. It's a relationship-based access control. The next will be some kind of policy-based access control, so policies based on resources. Which user is allowed to use which resource? And the system is meant to be extendable. So if we have further use cases where we need one more line of defense, maybe there will be a few in the future, the system shall be extensible. So let's dig a little deeper into our relationship-based access control. The only thing we want to do in the question of access control is check if an authenticated user has a directed relationship to the data he wants to access. So in our graph, we have only 3 terms. The first is the account. That's the authenticated user. That's the person or machine that wants to interact with our system. The next are entities. Entities is everything for which data is stored. This could be, for example, a person. It could be a company, or anything we store data for. And the third, relationships. Relationships between accounts and entities. And with these 3 terms, we can describe the whole system that we have in our graph. So if this was too theoretical for you, and I bet it was, so let's take a look at our graph. I've built a small browser guide based on the Neo4j browser. And I will guide you through our graph in a few steps. So the first thing we need is an account that is part of our system. So I'll create an account. And as you can see, this account, his name is Philip Price, has two media he uses to authenticate. So he has a smart card, and he has username and password to log in. He can use either of them. The next we need is an entity. The entity we have here is eCorp. eCorp is the company that Philip Price is working for. He's the CEO. And in our graph, every entity has at least two nodes. That is the principals node, where every user is connected with. And we have a content node. The content node contains the ID every data is connected to. So it's some kind of primary key to your data. So I'll add this to the database, and it simply comes up with the structure. Now, I've mentioned that we have principals within our entity. And we have, in general, two types of principals. And the first type of principals are internal principals. So these are persons or systems that belong to the entity we are talking about. So in this case, I've already introduced Philip Price. So I will add him as an internal principal to our graph. And as you can see, here we have Philip Price. Here we have eCorp with its contents. And we have a directed relationship from every authentication media of Philip Price and can connect to at least the principals. As you can see, there's no connection to the contents yet. So that's what we need now. If we query our graph, if Philip Price has access to the contents of eCorp, the result is that there are no records. So he needs permission. Permission is a simple relationship between a group, which is in this case the member group, and the contents. So we have Philip Price, and we have the contents of eCorp. And if I expand this one, you see this is the contents of eCorp. So next, we have personal data, because Philip Price uses the system not only to work with the data of eCorp, but he also has personal data. So we add the same structure we have with eCorp for Philip Price, also for him as a person. So there is his entity. The red node is the entity. And we have Philip Price as the account. And if I expand that node, I have the members node, the internal node, principals, and there is eCorp. So now Philip Price has permission to access his personal data and the data of eCorp. Next, Philip Price is the only one in our system yet, so we need some more users. So we add Terry Colby. He's the CTO of eCorp, and he needs the same structure as Philip Price needed. So we have Terry Colby as an entity. We have him as an account. And if I expand this account using the members node, we come to the contents of eCorp. So now Terry Colby, as well as Philip Price, has access to his personal data and to the data of eCorp. Now, these three entities are more or less one company. So there's not that much collaboration in this system. So let me introduce you to another company. This company is F Society. And let's assume they are the tax consultancy of eCorp. And this is what we come up with. We have 2 accounts in this graph. We have Darlene Alderson and Leslie Romero. They are both members of F Society, and both of them have their personal data, and they are allowed to access the data of F Society. Then the next is, now we have 2 more or less split parts of a graph. To connect these 2, we have the option to invite another entity or another company to access our data. In this case, as I've mentioned, eCorp wants to have F Society to do the tax declaration, for example. We need to give F Society access to eCorp's data. But the problem is eCorp doesn't want to have the overhead of administrating the users of F Society. So there's only the connection between the 2 companies and not between eCorp and the users of F Society. So we have an invitation, and the invitation is built by 2 nodes. We have a node for eCorp. This node is managed under the entity of F Society. And we have a node from F Society, which is managed by eCorp. So if eCorp doesn't want to work with F Society anymore, there's only this node that needs to be deleted. And then after the deletion, there's no more access for any employee of F Society to eCorp's data. So now we have some accounts and we have some content nodes. So we can run a few queries to see if a certain person has access to any data. For example, this is the ID of Darlene Alderson. We don't have really names in our graph, so I use IDs. And we check if Darlene Alderson has access to the personal data of Philip Price. I have never added any node or relationship between Darlene Alderson and Philip Price contents. So the answer from Neo4j is there are no records for this query. When we have this in our system, the access to the data is denied. So a user won't get access to the resources. But if I check if Leslie Romero, as an employee of F Society, has access to eCorp's data to, for example, do the tax declaration, we receive the relationship between Leslie Romero and the contents of eCorp. And he uses his smart card to authenticate against our system. So that was very simple, our graph. So let's get back to the presentation. So where to go from here? This was a simplified model of our graph. We have a few more group nodes. These group nodes are used for administrative privileges. So every administrator or owner within an entity has a connection, a relationship to this administrative nodes. If you have connection to these administrative nodes, you are allowed to add users, to give users access to your own data, and to manage the connections to other entities. Another point we can add to the graph, that's something we are actually not doing, is you can do more details within the contents node. So currently the contents means all data of an entity. But you can split down into, for example, like resources, like tax or accounting within the contents node, and then you can give dedicated access to only the tax data. So that's my presentation. I'd like to thank you. The slides can be downloaded from SlideShare, and there's a link to our GitLab page, and there you can find the browser and a short introduction how to use the browser.